Hi, and welcome to my video series of biotechniques explained in 5 minutes, where I explain a concept of biotechniques in less than 5 minutes or so. If you haven't yet subscribed the channel, hit that subscribe button. Why are you waiting for? My lectures are also present in An Academy, which is India's biggest learning platform. In order to avail my lecture, you can use my code AP10, which would give you 10% discount. So today's topic is radial immunodiffusion. Let's learn about it. So this is a method by which we can roughly quantify what is the concentration of antigen in a patient sample or in a fluid. In order to perform that, we need a particular petri dish which is already coated with agar. Now, in that petri dish, there would be antibodies distributed all over against the antigen which we want to measure. So, the antibodies are all over the place inside this petri dish. Now, inside that, there is a well where we are going to put the patient derived sample or our sample antigen which need to be determined. Now, after putting the antigen would start diffusing out from the well in all the direction in a radial fashion, right? Now, let's look at the antigen and antibody interaction in a graphical format. Now, before that, let me tell you that in the situation where the antigen and antibody ratio is a equivalent ratio and the equivalence is reached, then what happens is there is a precipitation band or precipitation radius is forming like this. Now here we are going to talk about the um, antigen antibody amount and how the precipitation would look like, or what type of interaction would be there. So when there is excess of antigen, there is no precipitation because there is too less antibody, and this is the situation very close to the well. Now in the zone of equivalence, there is a perfect ratio between antigen and antibody such that this precipitation reaction can take place and a visible precipitate can form. And there is an antibody excess zone which is far away from the well, where there is more antibodies, less antigen. So again, precipitation does not take place. So precipitation take place in the zone of equivalence when there is a ratiometric balance between the antigen and antibody. And this is the key aspect of this test. So how we can use it? In order to use that, first we have to load some controls. So in this coated slide where we have all the antibodies there, we are putting three standard samples of an antigen of known concentration. We are first putting known concentration, and then we are putting a patient derived sample and try to measure what is the concentration of it. And as a result of putting the antigen in these wells, it would diffuse radially and form a precipitation ring. And this precipitation rings radius can be measured. Now we have known standards which are previously known, the concentration of antigen, and looking at the test antigen, which was a patient derived sample, we can roughly have an idea that what is the concentration. So from this particular example, you can see the test antigen concentration is somewhere between the antigen that is present in the first and the second well. So that is how we get a very crude and rough idea about how much antigen is present in the sample. But honestly, this technique these days has no validity. First of all, it is qualitative, not so quantitative. We have very good techniques such as ELISA, such as radial radio immunoassays, and all of these things. So this particular technique is pretty old, but that time it was good. So we kind of learned about the basic principles behind the technique. And if you want to know more about the ELISA and more about radial immunoassay, I have other videos on that. So do click on the link at the end of this video. So thanks for watching. If you like this video, give it a quick thumbs up. Don't forget to like, share, and subscribe. Thank you.